I felt like I had to click everything more times than normal there.
It kind of did.
That was weird.
Yes.
This skill, hey, listen, once we start grooving synthetic division, your assignment goes really fast today. And you'll actually, if you're even remotely mathy, you will actually find yourself enjoying the process. I know that that's hard to believe for some people, but there's a feel to synthetic division that's so nice. Your ability to use this skill is critical to where we go next. I almost today started with finding zeros of unfactorable polynomials. They're technically not unfactorable. They're just unfactorable with our skill set. And then I decided, wait, we can't really go down that road until we acquire the skill that allows us to do the work. And that skill, I was like, duh, is synthetic division. Of course, why would I think you would know this? So real quick, before we get started, I just want to explain to you what is going on kind of behind the scenes here. So what you've been doing is taking polynomials and factoring them down, and then acknowledging that those little things called factors create places where a graph crosses through the x-axis. So we're going to try to make another sort of connecting piece to that today. That's kind of the goal here. So this part might not make sense, and you're welcome to give me the 5-star Uber rating, 1 to 5 or 0 to 5 when I'm done. Let me know, because this one is a little gray. And again, I can knock this. Let me pick one on the practice quiz. I'll just pick a random problem here. So we had a polynomial early on in one of our problems, and the problem was the function was f of x equals, and I'm going to pick a couple more until you can kind of nod your head at me and say, yeah, that makes sense. I see what you're saying. So we had a problem on our assignment number 9 long time ago that this was the function, and your job was to do what we've been doing. Find the zeros, consider the end behavior, graph the zeros, sketch the graph, do the intervals, all that same stuff. So anyways, when you factored this down, and this was a week and a half ago, FYI, but you have done this problem before, assuming you're a person who does your homework. You factored this down into 2x plus 5 times x plus 4. And I'm going somewhere with this. This is going to be the stretchy part where you either say, yeah, wow, that makes sense, or what are you talking about? The fact that we get answers out of these, the fact that we now know that the graph crosses the x-axis at -5/2, and the fact that the graph crosses the x-axis at -4, it means this. It means that when you take this, here comes the stretchy part, so feel free to give me funny looks. This is the connection. It means that when you take the polynomial 2x squared plus 13x plus 20, and if you were to divide it by the polynomial x plus 4, you would not get a remainder. And not getting a remainder in mathematics is a really big deal. Not getting a remainder means that you're on the x-axis. A function's value is determined by the remainder to a division problem. I can also say, oh, and by the way, the answer to this would, of course, just be, as you knew this from like 5th grade. If you know that 3 times 4 makes 12, then if you take 12 divided by 4, what do you get? 3. And if you take the other guy, 12 divided by 3, what do you get? 4. So fundamental understanding of division and multiplication would tell us that if we took the original 2x squared plus 13x plus 20 and divided it by one of the factors, the answer would be the other factor, right? Common sense. Without a remainder. And conversely, we could say that if we took the original polynomial and we divided it by the other factor, we also can say we would not get a remainder. What would the quotient be? X plus 4, right? When you can divide two things, when you can divide a polynomial by another polynomial in mathematics and not get a remainder, and I understand there's a lot going on here. Like, I'm not going to show you polynomial long division today. I have no intentions. I'm going to show you something called synthetic. It's super slick. But when you can divide a polynomial by another polynomial and get no remainder, that means that the second polynomial, the divisor one, the one you divided by, is a factor, which is a big deal. It means you're at a 0. So there's a connection there. So the question today becomes, how can I take a polynomial and divide it by another polynomial? Let me give you another example. I'm just going to pull one off of something old. Here's a nice thing here. Let's revisit an old problem. And I think it'll be with this problem that I introduced to you, synthetic division. This feels like this will be, and maybe not. This may not be a good one. Oh. Yeah, this one's gorgeous. We got a winner right here. Okay. Let's do f of x equals, I don't want your first example of synthetic division to be all wacky, right? What kind of rude introduction is that? So here's a polynomial function. Now, you've done this problem also. I say this assuming you do your work. This was on assignment 11. It was problem number 6. So you probably did it about 4 or 5 days ago. Let's factor it. I'm going to try to make a connection here. How would you factor this down? Pull out a negative. Good job. You guys, it's like clockwork for you. And then you'd be left with x to the third. Change the sign, 4x squared. Change the sign, 16x. Change the sign, 64. All right, the power of a negative. And then we would wall it down the middle, and we would group it. And on the left side, what would we pull out?
X squared.
Leaving behind what? X plus 4. This class is so much more fun to teach when we spend 5 weeks on factoring, because I don't have to stop and explain. Oh, it's so nice. And then, of course, on the back half, what do we pull out? Negative 16. And then that leaves, of course, with x, change the sign 4. And then we can see now that our answers are, if we lay out the factors, they are negative, which is pointless, right? And then we have the commonality of x plus 4. And then you see this, I probably don't need to take the middle step. You see the yellow and green difference of squares, right? What's it going to factor down into? Good. So here's what this means. I really hope that this comes out right. It means that these things are factors of the original polynomial, which means that when we divide the original by them, we'll get no remainder. This is a perfect time and example for me to now show you what it looks like to do division. And again, we're not going to do the harder division. The harder division is necessary, just not today. Today's are all really sweet and conducive to the synthetic type. So what I'm trying to tell you here, if it's coming out even remotely well, is that if I take the original problem that was up at the top of the TV about a minute ago, and I divide it by x plus 4, I'll get a remainder of 0. Same with x minus 4, I'll get a remainder of 0. Which leads us then to the inevitable question, okay, fine, shut up, just tell me, how do I divide? Like, you've never divided polynomials before, I don't think. I mean, I taught you Algebra 1. We sure didn't do it there. Christian might have, because he's kind of new to the scene here. But, I mean, there's no way that you guys have done this before. So, again, the question is, how do I do division? Well, there's 2 types of division. There's long division, which is laborious and then there's synthetic. So I'm going to show you synthetic. So we're going to go back to the original. I'm going to copy down the problem again. which was
Negative x
negative x cubed
minus 1 plus 16x plus 16.
Good. And we are going to divide it by any one of the three factors that I just had up on the TV. And they are up there at the top of the screen, right? So let's pick one. Who do you want to divide by? X plus 4, x plus 4, or x minus 4? Then let's divide by x minus 4. And I want you to see, I hope this is one of those moments in your education where you say something like, wow, that's neat. Because something's going to happen. And I want you to see in math how we do this. How can I, through inspection, look at a polynomial and determine if it's divisible evenly by another polynomial? Well, here it goes. So step one when doing synthetic division is to take your polynomial, the dividend. This one, by the way, is, of course, you know, this is called the dividend. So you take your dividend and you make a list from left to right of the coefficients. Those, remember, are just the numbers in front of the letters. So I'm going to take that polynomial and I'm going to gut it down to be -1. And if you want to know where I got that, it's because that's the number in front of x cubed. Pay attention for missing terms like gaps. You'll notice I picked this one because there are none. That was why it caught my eye. The gaps, what do you think we do if there was a gap? You put in zeros, right? You need to fill all gaps. Like, it has to scaffold down 1 degree at a time. But this is a perfect warm-up example because the exponents are sweet. They go 3, 2, 1, 0. Ah, love it. So I'm going to head over from -1. What's my next coefficient? -4. Next. And you do not need to put the plus or the minuses. What you're putting in are just either positive numbers or negative. So we cease to think of them as minuses and pluses, but negatives and positives instead. Got it? You with me there, Bud? Nice. Now what I'm going to do is I'm going to set up an upside down division sign, and I'm going to make sure that I leave space underneath the numbers, and you'll see why here in about a minute. Like, this is what it should look like. Get used to this. You're going to do this a lot, like a lot. And when I say a lot, think of a lot, add some, square that, and then add a lot. You're going to do this a lot. Now, on the outside, we're going to put a number, and the number is not -4. The inclination for people is to say, I bet this has something to do with it. And it does. But you want to do the opposite of that. And the reason for that is because, like, think about, let me go back up for a second. If I asked you, what answer do we get from this factor, what would you say? You would say x equals +4. So that's the number that we're synthetically using. It's actually called synthetic substitution. It can be called synthetic substitution from one perspective, synthetic division from another perspective. So when we're doing synthetic division, we use not what we see, but the number that would make what we see equal 0. So in this case, since x minus 4 has an answer of +4, we're going to put a +4 out here.
So you would just use opposite?
Opposite. Or, I mean, that's going to come back to haunt me. Use the number that makes the divisor equal 0, because fractions will come into play eventually. Are we okay so far? Now, what you have to do is spend a little time today and memorize this process. It's real slick and easy. You basically only have to know how to drop numbers, add, and multiply. And if you can do those things, then you're a rock star. So here it goes. Follow along. Step 1 is you take that first number and you drop it down below the sign. Just drop it. Don't modify it. Drop it. And now you're going to find yourself repeating the same 2 steps until you get to the end of the division problem. So what I'm going to do next is I'm going to take the number on the outside, 4. You see where I'm moving my pen? I'm going to multiply that 4 by that -1, and I'm going to get -4, and I'm going to place the answer right there. I multiplied this by this. Don't worry. This is, once you get this, you won't even think about it anymore. So you multiply those together. 4 times -1 is -4. Does anyone want to guess what we now do with those 2 numbers? We add them, actually. So we're going to add them together. What's -4 plus -4? So I'm going to place a -8 down here, and I'm going to reset the algorithm. What always happens is after I add, I find myself multiplying. So you go like this. You multiply, add, multiply, add, multiply, add, and you just keep doing it until you run out of stuff. The number that goes in this yellow box eventually is the remainder. And if we're going to sit here and make the claim that x minus 4 is a factor of negative x cubed minus 4x squared plus 16x plus 64, then by definition, if you're a factor of something else, when the something else divides by you, there can be no remainder. That's like a fundamental principle of like 4th grade math, right? So let's continue the algorithm. So now let's remultiply. Take the number on the outside, multiply it by the new kid on the bottom. What do you get? You get negative 32. So we're going to place a negative 32 here. And then we're going to add. And that's negative 16. And then we're going to multiply. 4 times negative 16. It's not 64. It's negative 64. And when I add 64 and negative 64, I get 0, exactly as I would have theorized. Again, if I'm going to sit here and make the claim that something is a factor, I better be able to back it up. Now, going back to the beginning, I'm going to show you a couple different things here. Going back to the beginning, let's say, so I'm going to erase a bunch of stuff now. All right, I hope that's, please, yes.
So, the stuff that we have is negative 1.
Yep. Those are from up here. Good question, Ellie. So those are right here. There's negative 1, negative 4, positive 16, positive 64. Those are just, we're not taking the x's, we're just taking, they're called the coefficients. They're the numbers in front of the x's.
Thanks.
You're welcome. Any other questions about that? Because I multiplied. I'm running out of colors, but I'll use white. I always, these numbers that where I'm moving my pen always come from multiplying their predecessors. So this number is part of every multiplication problem. The one I'm circling in white, he multiplies by negative 1. That's why I put negative 4. Then he multiplies by negative 8. That's why I put negative 32. Then he multiplies by negative 16, and that's why I put negative 64. Does that answer? I vandalized the living daylights out of my poor problem there. Everybody okay? Okay, that was good. It gave me a chance to pour a fresh cup of coffee, so thank you. I'm going to erase some stuff, like a lot, so excuse me while I go happy with the back button. Whee! Man, my finger is super fast. Okay, let's go back to a conversation that we had before. When I had these factors laid out up here on the board, I asked you guys, and you guys all really seemed to take to x minus 4. You guys loved x minus 4. Well, what would have happened if when I had said, which one do you want to divide by, if you had said x plus 4? Shouldn't we get the same result?
Yeah.
If we can claim he's a factor, then his division should result in no remainder. So let's go back in time and pretend, bless you, that when I had said, what do you want, that you picked x plus 4. So let's go down here now and let's modify our math problem. And you might just want to rewrite the whole thing. I have the benefit of the back button. You don't with your pencils. So you might just want to start all over. So recopy the coefficients, the negative 1, negative 4, 16, 64. But this time, rather than dividing by x minus 4, we're dividing by x plus 4. It's not like this isn't a surprise. I'm not trying to surprise you. Like, you already understand the inevitability of this. Like, you know what we're about to verify. We just want to see it with our own eyes. So if we're dividing by x plus 4, what number should we be putting on the outside? Nice job, you guys. So we're going to put a negative 4. Thanks. Did you make that? Nice. Is this from culinary class? Do you make this in like cooking class? Yeah. Dope. Thanks. Oh, there's me getting free food from a kid on my recording for the day. Yay, Mr. Ahern. So negative 4 goes out here, and I'll pause right here because there's no sense. You guys are great with your questions. I'm proud of you for that. Does anyone have any issues or questions as to why I put negative 4 out there? All right, so now let's practice the process again, synthetic division. It's just, it starts going. You almost don't even have to think about it after a while. If we're doing things well, if our factoring was correct, if our conjecture is correct, then we, of course, should wind up with a 0 in that box. If not, then something with our factoring or something in our synthetic math was wrong. All right, step one,
Drop the negative 1.
drop the -1. Boom, shoot it down below, and now begins the two-step process.
And then we'll
Times, add,
multiply.
times, add, times, add, over and over again.
Multiply the
Multiply these, it's +4. Add these together, 0. Multiply these, 0. Add these, multiply these, I'll be darned. Now, to even blow your mind potentially even further, what happens is when you lay out a bunch of factors, by the way, are you with me so far?
I have one question,
Awesome.
sorry.
Don't be, why are we sorry for having a question?
So.
It'd be
about-
$5, please. Sorry,
Yeah. But I'll bring you food.
you're good.
The factors above, so we have 2 +4s, does that matter at all?
Yes, I'm gonna show. That's funny. It's almost like you read my mind. Yes, we're clearly clicking because that's exactly where I'm headed next. So I want to show you guys now the way that you can actually, and this is going to become really handy. Not crazy handy in this class, but as you take more classes, if you choose to go on, you'll have problems where what we're about to do is so fun because you start with like this 8-term polynomial and you chip it down, and it almost looks like an upside down staircase. So I'll show you what I mean. So this time, rather than start the problem over, what we're going to do is we're going to piggyback off of a previous success. So what I want you to do right now with this in your notes is I want you to continue now and draw a second stage, but draw it right off of that one. And notice that my division sign stops at the 16. I don't go past, I certainly don't want to go to the remainder of 0. That would be weird. Now, Ellie asked the $1 million question, and oh, was it a good question? She said, hey, I remember back at the beginning, we had factors of x + 4, x + 4, and x - 4, right? So based on what I'm saying or thinking, I think that I make the claim that we already tested -4 once and it worked, right? So I can take him off my checklist. But there's another version, another iteration of him right here. So what I'm thinking is, I bet if we put -4 synthetically in again, guess what happens? It works again. And you'll find that the multiplicity of a root, if you have a root that occurs 5 times, you can synthetically substitute it, boom, 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 5 times to chip away down a polynomial down to its little guts. So let's do it again. Second verse, slightly different than the first. So we're going to put -4 out here again. And again, we're doing it again because our factoring told us that we could. So the algorithm again is very repetitive. Drop the -1. What is -4 times -1?
-4.
It is not
Or
-4. It is
+4.
+4. When you add these, what do you get? You get 4. What is -4 times 4? What the what? I got another remainder of 0. And just to further scrape all the meat off the bone, I believe up here in the corner, that checks -4 and -4 off my list. Who else should work? +4. So you can actually scaffold all the way down and just rip all the meat off the bone and synthetically divide to your heart's content. If you know something's a 0, it should synthetically work. So I'm going to put a +4 out here now, and you're probably not going to be surprised by the result. Drop your -1. What's 4 times -1? -4. And that's all the further you can ever go. But look at these zeros. Check, check, check. That's a verification that those are in fact factors, which are you being sarcastic, Bryce?
No, yeah. Maybe.
You little turkey. Let's do another one. All right, don't worry. There's going to be lots of practice and work time for this, but I got some good ones on my note card here. I wrote these out for you last night. So here comes the way delta math is going to look. Delta math is going to ask you to take a polynomial like this. And it's going to ask you to divide it by a polynomial like this. And in case at some point you feel inclined to ask the question, when does this and does this not work? The answer is it only works for linear divisors. Okay, that means that your divisor cannot have like an x squared in it. If that's the case, then we have to go to long division, which I'll show you, but not today. Okay.
Also,
Sure.
what about, if it doesn't go 4, 3, 2, 1?
That question will be answered in a couple examples from now. Well, by that I mean like 4. Sorry. So let's get to it. Here we go. This one's going to go quick. Our question is really, are x plus 5, are you a factor of that guy? If you are, then I should divide evenly, right? So to set up my synthetic division, what are my numbers going to be? 314, -8, -14, +5. Put your upside down division sign, leave room to write numbers, and what number will go outside? Good job, guys. -5, because we're dividing by x plus 5, so we have to do the number that makes it equal 0. Opposite, as Kinsley said. All right, do your thing. It's going to go quick. If you have bad basic skills, you're always going to be slower, and it is what it is. So -15, add -1, multiply 5, add -3, multiply 15, add 1, multiply -5. What can we say about this division problem? There's no remainder, so what does it mean about x plus 5? It is a factor. This is going to be what triggers us now to be able to do the next little unit I have for you is I can find factors in other ways than just standard factoring, like grouping and stuff like that. All right, I'm going to skip a couple of examples. I'm going to head on to, I don't remember which ones have remainders. Dang it. So we might not be able to skip any because I even thought as I was writing these down, I was like, dude, write down remainders. And then I think I saw something shiny or a squirrel or something, and then I moved on. So we're dividing this 4th degree 5-term polynomial by x minus 4. I know these are annoying. When you get to your assignment, you won't have to write all this down because the screen will have this and you'll just put the synthetic numbers. So it won't be a pain. Shouldn't be. There's no gaps, so we're not to that part yet. So the numbers I'm going to lay out are 2, -7, 5, -30, -24. Synthetic divide. What's the number outside?
4.
+4. Good job. All right, you guys whip through that algorithm real quick. I'll give you it shouldn't take you more than about 15 seconds to whip that out. It's just times tables and adding. And then I'll get caught up to you here. I'll give you a head start there. I should be going quick for you by now, right?
How
did I get what?
Oh, yeah.
Pricey, you okay, bud? Yeah. Multiply, add, multiply, add, multiply, add, multiply, add, multiply, add. Just rinse, repeat over again. Next one. I'm sorry, I do have to hit all of these. I realize you understand the process, but something is about to change. And I just don't know, since I didn't make notes, I don't know when it happens. Sorry. All right. Once you understand the rational root theorem, and once you understand, like a week from now, all the stuff I'm going to throw at you, you'll look right at this and know that this is not going to work. There's reasons for this. This one will have a remainder, and my job next is to teach you how to do it. How do I write my answer when there's a remainder? So let's do it. So the numbers are 1, 5, -26, and 11. No gaps, so I don't need to fill any holes. 3, 2, 1, 0. Upside down division, that sucker. And what do we put outside? All right, go ahead and whip through the algorithm. This isn't like a Houston, we have a problem kind of moment. This is just Uh-oh, I haven't seen this before. So when the remainder comes out to be something other than 0, it means that x minus 3 is not a factor of the original polynomial. So the way we write this out is we write the, oh boy, I hope you're still listening. This is called the quotient. This, as you know, is called the remainder. And this, as you know, is the divisor. In mathematics, the way we express, and you've been doing this since 4th grade, you just don't know it, but when you write out the answer to a division problem, it always goes like this. It always goes quotient plus remainder over divisor. So having said that, how do I write my answer? Well, my answer is, here it goes. And this will correlate back to some other problems that we just did. This 1 that I'm circling in purple stands for 1x squared. This 8 that I'm circling in purple stands for plus 8x. And this minus 2 or negative 2 that I'm circling in purple stands for negative 2. That is called the quotient. Now, you might wonder, where did you get that? Well, it's always just, you've heard people say, chip away at the stone. What degree was my original problem? What was his highest exponent? 3. If I synthetically chip one layer off, it drops to a 2. So those 3 red numbers at the bottom are the coefficients of a new polynomial, the answer, if you will. Now, since this one has a remainder of 5, I'm simply going to put plus 5 over x minus 3, and I'm done. Quotient, that's the answer. So let me go back. I feel like I obviously left some stones unturned. Going back to these problems, I got so wrapped up in the excitement of showing you this that I forgot to actually tell you how to write your answer. Do you guys remember this problem? You just did it about 7 minutes ago. You see how the original problem had a degree of 4?
Yeah.
What will the degree of my first term be for this? It'll be 1 less. Good. So my answer to this problem is 2x to the third plus 1x squared plus 9x plus 6. Notice this time I didn't have to write it as q plus r over d. Why not? Because there's no r. Okay. Let me scroll back up and we'll also modify another example that you've already done. You remember this problem from about 10 minutes ago?
Yeah,
Good job. So again, these numbers in my answer down here are giving me the coefficients of my quotient. So like this one would be 3x to the third minus x squared minus 3x plus 1. So those numbers that you get at the bottom are the coefficients of your answer. Got it? Am I killing you here? Sorry, this wasn't supposed to be a 40-minute lecture. It's just, you never know. I never know. Let's go again. Monday will, of course, be a work day. I hadn't anticipated that, but based on this lecture, then, of course, that would be the case. I'm not going to send you home with work over weekends. I know you're thinking like, God, it's the 5th one. I get it. Let's set it up for synthetic. So what numbers would I string across the top? 2, 0, -1, 21. And I saw a couple heads perk up when I said 0. This problem exists for that reason and that reason alone. You've got to fill the gaps. And so this will get you, watch out. You'll notice that the exponents didn't scaffold smoothly 4, 3, 2, 1, 0. They went 4, 2. You're like, you got to get up earlier than that to fool me. So there is a missing term right here where this red arrow is pointing. And it is 0x to the third. You must acknowledge that with a 0 in the proper place. Got it? And that is the answer to the question of what happens if there's a missing term. What if they don't go smoothly?
You can use that if it's like Like say it was like 2x to the first, and x to the third, and then it like skipped x to the second.
You mean like maybe our next example? Yeah, something like that. Yes. Everybody okay? What's that? Because this polynomial, if written out correctly, would be 2x to the fourth plus 0x to the third minus 1x squared, so on and so forth. Do you see how this term that I'm putting a red box around is not actually there? Look at the exponents. They need to go right. If there's any missing powers as we go down the staircase, we need to fill them in with zeros. And then the process is the same. What number do we put on the outside? And we drop, and here we go. Drop the 2, multiply, add, multiply, add, multiply, add, multiply. What can we say about x plus 2? It's a factor. Very good. What is my answer then to this problem? Dope. Let's do one more, then I'm gonna be done. I'm sorry I took your whole hour, but did you learn a lot today?
Yeah.
Good. Then I'm not sorry, I guess. So let's do one more.
Can you go back?
Last one for the day. And then, like I said, I will modify my plans. I had expected like 20 minutes of work time today. Clearly, Ulysses S. long-winded up here ruined that. So time well spent, though, if you're learning good mathematics. That's what I say. So clearly there's a theme here, and you're not going to fall for it this time. You're not going to mook it up this time. This time, when I say to you, what numbers do we string across the top? You're on to me. What are they? 1, 7, 0, negative 11, 9. Pay attention to those exponents. They went 4, 3, missing 1, 0, right?
Yeah.
And then we're going to synthetically substitute the number what? What number goes out here? Positive 1. And let's do our thing. All right, drop your 1, boom, multiply, add, multiply, add, multiply, add, multiply. What can we say about x minus 1? It is not a factor. It means that the answer to this problem has to be expressed as q plus r over d. You can't just write the q. So what is my answer going to be?
1x to the third. Yeah, right. Plus 8x to the second. Plus 8 minus.
Plus 8x.
Oh yeah, plus 8x
Minus 3.
times.
Plus.
Plus 6 over x minus 1.
Dope. What a great way to end the hour. Boy, good job today, guys. The final answer to the problem is in this purple box. Yes.